everybody, welcome back to another LeetCode problem. So today we're looking at LeetCode112. It's an easy, and its name is called Path Sum. One thing I want to talk about with this video and with this problem is sticking to our patterns. So I want to show you today a depth-first search pattern, a solution to this that has a form that you can extend to other problems. So if you've happened to go through the solution tab on this video, or excuse me, on this problem, you'll see that there's a lot of really creative solutions and a lot of kind of compact depth-first search formats or versions to solve this problem. And what I want to encourage everyone to do is to stick to a really more simple pattern that we can extend to more difficult problems later. So without further ado, let me kind of get into that and show you what I mean. So, okay, let's talk about this problem. We're given a root of a binary tree, and then we've got this integer called target sum. And basically, we need to return true, which is nice, because a lot of times you have to return like a position in the tree or something like that. So for this one, we just have to return a Boolean. Return true if a root, so the very top of the tree, to a leaf, so a node with children values of none, if any path from the root to the leaf equals the target sum. And they've defined a leaf here as a node with no children. How do you know a node has no children? Well, its children have the value of none. That's in that class definition up here of tree node. Okay, so if we look at this example right here, one of the very first paths that you can check if you go on the left side does indeed equal the target sum. 5 plus 4 is 9, plus 11 is 20, plus 2 is 22, and that equals the target sum. And then they show us an example here where none of the paths lead to the target sum. You would get 3 on this side and 4 on this side. And then the empty case, so if the root, if there's no tree, if the root is just like a list, they're showing it as a list. Really, they serialize this. I'm sorry, this is the serialized version of the tree node object. That's what they show us here. The target sum is 0, but it's still false. This is a hint, basically, that if we get nothing, we don't need to return, we don't need to add up like a 0 value. We need to make sure that we indeed have nothing. Okay, so what do we want to do here for our depth-first search pattern? With DFS, we can have a lot of arguments the way I'm going to design this, but for this problem, I think we're going to need to have the root. Let's change that name to node, actually, so we don't confuse root and node. And then what I'd like to do is I'd like to keep track of the sum of where we are in the tree. And I don't want to alter the target sum value itself, so we're going to make a new variable called total. And then, we need a definition statement, don't we? There we go. I was wondering why that color coding wasn't happening. And then what do we want to do here? Well, basically we need to check for basically if the value is none, and then if it's not, then we need to increment total. And what else do we want to do? After we increment total, we want to do basically a total equal to target check, and then some other things too, right? Because not only do we need to check for target, but we need to check for, is it a leaf? So is leaf. Because if, for example, let's say the target value were like 9 here, 5 and 4, okay, yeah, our total value that we're incrementing is going to be equal to the target sum, but it's not going to be a leaf, so we would not want to return true here. Okay, and then finally, what do we want to do? Well, we need to recurse, so we got to keep this algorithm moving forward. And then let's just keep going here. What do we want to do outside of this? Well, we want to call DFS on the root, and we want to start total off with 0. And then finally, what do we want to return when we get to the end of this? Well, that's kind of tricky. We don't really have that set up yet. So because Python has issues with local variables being assigned, what I want to do is I want to add something to the class that we can check, and I'm just going to call that result. So we can have something called result, and we're going to initialize this as false. And basically, if we don't find a solution, this value will never change. If we do find a solution, I want to flip this to true. And then what we want to do down here is we want to say self result equals true. There are other ways of doing this. We could have just a normal variable up here, but then we'd have to call global inside our function so that the DFS function knows it's not using a local variable. We could also instantiate a dictionary up here. That's another way of getting access to things because of the way that dictionaries are created in Python. And then we could just alter the dictionary value in here. But I think this is probably the best way to do this. Okay, yeah, so what next? So let's go through our pseudocode and actually change things. So if not node, then we want to return. We could return none here, but really just ending that loop, that stack, killing that stack entry is fine. So if we don't have the node, well, there's nothing more we can do, so return the function. Otherwise, we want to, what do we want to do? Total is going to be equal to total plus the current node that we're at, and we want to take its value. That, again, comes straight up here from the class definition. And then here's kind of the meatiest part. Basically, if total equals, we need an if statement. If total is equal to target sum, and now we have to do a couple different checks because we don't have, this won't work, right? We don't have some variable called leaf. We could do that, honestly. We could check to see if every member is a leaf, but no point doing that if we don't already have the total equal to the target sum. Okay, so if total is equal to target sum, we want to check and make sure, is this thing a leaf? How do we do that? Well, what we need to do is we need to say, and in the node, does it have a left member? So if it doesn't, then we're halfway there to being a leaf. And then we need to also check if the current node doesn't have a right member. If all of that's the case, then what we can do is we can take this variable up here and flip it to true, and then we want to get out of here. We want to end that stack call. We found our answer. Otherwise, if that isn't the case, it's not working well, we want to recurse. So what do we want to call? Well, it doesn't really matter which order we go in here, but we need to call DFS on the current node, and let's just start with the left because that's easy, and put the new value of total in. And then once we go left as many times as we can, we also want to go right again with that total value. All right, I'm just giving this a quick look over here to make sure that we haven't missed anything. Maybe you guys are finding all kinds of errors while I'm doing this. I don't see anything obvious. So we've got our return statement. Yeah, let's run this and see what happens. This is not looking good if it's taking this long. Oh, yeah, that doesn't make sense, does it? All right, let's try this again. All right, that works. Let's go ahead and submit it and see if we pass all the test cases. That code wasn't slow, by the way, so I think LeetCode is a little slow this morning. Well, it's morning for me. I don't know what time it is for you guys. Wow, very slow. Well, we passed, but I don't know if my internet connection is slow or what, but we're having a hard time loading these up. Okay, cool. Wow, that's actually even better than I thought. So we're really top of the board here on speed, and memory is pretty good too. All right, so that was the pattern that I think you should follow. Or, find your own pattern. Find an extensible pattern that works as problems get more and more difficult. I can show you now a pattern that is simpler in lines and maybe a little more fun. It's something I ran a little earlier this week. By the way, I would code this up live, but earlier, you guys saw that when I was trying to submit, I was having issues, and it appears LeetCode is now having all kinds of issues. I'm getting internal errors and like a Cloudflare error, and some pages just aren't loading, so I'm not going to risk it. I'm just going to stay over here. So here's another solution that I ran, a little slower than the one from before, but who knows with this stuff, like exactly how, like I don't know how much kind of randomization goes on here, so it's hard to tell. But pretty comparable in performance. And what this one is doing, the reason it looks so much simpler is because we're not storing, a member variable. We're really just checking, hey, do we have a node? If we don't, return false. Increment our total value. Is it a leaf? If it is, return true. Otherwise, recursively go left and right at the same time, and then return. The outside function just returns the first call of DFS. The problem with this is that this recursive return statement inside the DFS function, it's cool, it's elegant, it works because basically we go down the left side and if we get falses, we keep searching, and then we go down the right side, and if we get falses, we keep searching all the way up to the first time that we get a true. By the way, you definitely want to use a Boolean operator here. Don't use a bitwise operator. This is going to short circuit things. So Boolean operators are short circuiting, meaning that like if the first recursive call on the left side of the tree or the second one or something like that finds the solution, we go ahead and return true, and this completes and we get a nice happy runtime printout. If we had a bitwise operator here, by the way, that's just the pipe symbol in Python if you've ever seen that. If we have the bitwise operator here, what's going to happen is even if the very first call over here finds the answer, the bitwise operator says, well, you got to do everything. Look for, don't short circuit. Look for all the solutions and then return true, return the first true. So nowhere near as performant. There are cases when you might want to use it, but this is not one of them. Anyway, yeah, I don't think this is as extensible because as we get to harder and harder problems following this format, our DFS function, sometimes it needs to return more than just true or false, more than just a Boolean in the recursive statement. Sometimes we need to return some state variables. Now, you could handle all that with like member functions for the most part, but then, well, sometimes you can't because the recursive call needs to keep different states at the same time. And so I think it's better to just kind of learn a longer, seemingly more complicated pattern at first, but then be able to grow with it over time and really learn it and hone it versus this, a little more elegant, but not even any faster and ultimately not as extensible. You can make this even shorter too if you want to have fun. So, you could increment the total variable inside the function call. You could also subtract from you could make total the value you want and subtract from it and check to see if the node value is equal to what's left in total. There's a bunch of ways you can make this fast. But, I still stand by what I said earlier. By the way, I think down here I have an example of when I used the bitwise operator just because I was curious if this will load. Yeah, LeetCode. Okay, fine. LeetCode is having issues. You'll have to trust me on it. The performance did show up. It was way, way worse. Anyway, thanks for coming to the video, guys, and I hope to give you a new solution real soon.